Okay, so there was a request to do one as an example. So I'm going to do number 5 because those of you who are here haven't seen number 5, and maybe that will help you. All right, so our problem says that a car whose initial speed is 30 meters per second slows uniformly to 10 meters per second in 5 seconds. Sorry, 10 meters per second in 5 seconds. Can you guys in the room see this? This isn't great. Okay, I'll try to write big so you guys can follow on the paper and you guys can read your own paper and follow along. So we know that the initial speed is 30 meters per second, and then it slows down to 10 meters per second after 5 seconds. So first is make a diagram of the situation. Second, make a graph, and we have a blank graph here to use. And then we're going to solve some things. We're going to figure out what the acceleration of the car is. And remember, acceleration is the change in velocity divided by the change in time. And the distance that the car travels in the third second. So from 2 to 3 seconds. So to do that, we can either do our change in position is equal to average velocity times time, or we can do the area thing. Or we can do both. Maybe we'll do both. All right, so for my graph, the first thing I have to do is divide this all up into sections. So I need at least 5 seconds of time. 1, 2, 3, 4. So I'm going to do every 2 of these is 1 second. So for my grid lines, I'm just going to skip 1 so that each 2 grid lines is 1 second. And then my velocity, my greatest velocity here is 30 meters per second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these can be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right. So I know that my initial speed, so my speed when time is equal to 0 is 30 meters per second. So I need 1 point at 0 and 30. And then at 5 seconds, my velocity is 10 meters per second. So I'm going to put that, I have to kind of estimate it because I did everything by 3s. But I'm going to put it right there. Grab a straight edge. Edge of the paper, straight edge trick. There we go. There we go. So now I have a graph. It asks me for a well-labeled diagram of the situation. So it says I have a car. This is just like we did before. Here's my road. So it's not a flying car. And then my car is on the road. And at time equals 0, my velocity is 30 meters per second. So what's the car doing if it goes from 30 meters per second to 10 meters per second? Is it speeding up or is it slowing down? Slower or faster? It's slower, yeah. And so that's what we see when we look at the graph, is that we went from a big velocity to a small velocity over time. So I got my diagram, I got my graph. So next, acceleration of my car. So if I do it with a graph, with the equation, my change in position is equal to my average velocity. And so to figure that out, it doesn't say what section of time. So I'm just gonna do it for the whole thing. So my initial velocity is 30 meters per second. My final velocity is 10 meters per second. So I've got to find the average between those two. It's going to be 20 meters per second, right? Times the amount of time, which is 5 seconds. So this is going to be 20 meters per second times 5 seconds, which is going to give me 100 meters. If you like doing this graphically, with the graph, you can figure this out by finding the area underneath the graph. So if I do that, I have to keep in mind that I've got a rectangle and a triangle, which makes it a little bit more complicated. Let's see, triangle plus rectangle. My triangle is going to be 1/2 times the base times the height, 30 meters per second. And I'm going to add that to, sorry, the height of my triangle is 20. It's 20 because it only goes from 10 to 30. That's why. And then my rectangle is going to be 10 meters per second times my 5 seconds. So 1/2 times 20 is 10, times 50, sorry, times 5 is 50 meters, plus 10 times 5 is 50 meters. So that's 100 meters. It's the same answer. For our acceleration, we're just going to do our change in velocity divided by our change in time. Our final velocity is 10. Our initial velocity is 30. This is our meters per second divided by 5 seconds. So we've got minus 20 meters per second divided by 5 seconds. And that's going to give us minus 4 meters per second squared. What questions do you guys have? Did these seem very doable to you guys? Yeah. Okay, so if you guys don't have any questions, you can go ahead and get started on the rest of those.